Hi everyone, and welcome to today's tutorial. In today's tutorial, we want to look at an aspect of the curve of functions. We want to study how to find the set of values for which a function is increasing and set of values for which a function is decreasing. Okay, when we say a set of values for which a function is increasing, we are talking about the graph of the function. If we look at this graph, we will see that from this point to a certain point up here, the graph is increasing. And from that point coming this way, the graph is decreasing. So how do we get a set of values of x from this point to this point where the graph is increasing? And how do we get the values of x from this point to this point where the graph is decreasing? Okay, that's what we want to study, or that's what we want to solve in this tutorial. All right, so let's get started. We are given the function f of x is equal to x cubed minus x squared minus x plus 5. This is the expression of that function. Now, this is clearly going to give us a curve and not a straight line because the degree of this polynomial is more than 1. Remember, if the degree is 1, ax plus b, then it will give us a linear graph. When the degree is more than 1 or less than 1, we are supposed to have a curve, not a linear graph. All right, this is going to give us a curve. So what are the values of x for which this curve will be increasing, and the values of x for which this curve will be decreasing? Now we have increasing and strictly increasing. We also have decreasing and strictly decreasing. All right, so we're going to see those various situations as we solve along. Now, for a function to be increasing, it simply means that the gradient will be increasing. So we'll be looking at the gradient of this function, solving for those values of x for which the gradient will be increasing or greater than or equal to 0. The gradient function will be the first derivative of this function, which is f prime of x. That first derivative will be 3x squared minus 2x minus 1. All right, when we differentiate this function with respect to x, the first derivative, this is what we get. This is called the gradient function. Now, for increasing function, the gradient, for increasing function, the gradient must be greater than or equal to 0. So we want to solve these inequalities. What are those set of values of x for which this inequality is valid? F prime of x, this is it there. So we are solving 3x squared minus 2x minus 1 greater than or equal to 0. That's the inequality that we want to solve. The left-hand side is a quadratic expression, so let's factorize it. If we collect our coefficients carefully, we have a to be 3, b to be negative 2, and c negative 1. If we put that in the quadratic formula, because we want to factorize, we put that carefully, we're going to have negative 2 plus minus the square root of negative 2 squared minus 4ac all over 2a. That's going to give us negative is positive 2 plus or minus the square root. Negative 2 squared is 4. This negative multiplied to that negative is positive. 4 multiplied to 3 is 12. All over 2 multiplied to 3 is 6. Okay, so that will give us x equals 2 plus minus the root of 16 all over 6. So the first root will be 2 plus root 16 is 4 all over 6. This gives us 6 all over 6, which is 1. So our first root is 1. The second root will be 2 minus root 16, which is 4. So it's 2 minus 4 all over 6. This gives us negative 2 all over 6, which gives us negative 1/3. So the second root is negative 1/3. Negative 1/3. So we have our two roots, 1 and negative 1/3. So we have x equals 1, x equals negative 1/3. These are our two roots. All right. So we're going to write our inequality now in the factorized form. We're going to write our inequality in factorized form. This inequality we're going to write it in factorized form. Remember again that x equals 1 is a root, therefore x minus 1 is a factor. So for the first root, x equals 1, we're going to write x minus 1 as the corresponding factor. And then x equals negative 1/3. X equals negative 1/3. It means 3x is equal to negative 1. So 3x plus 1 is the factor. So we'll write it here. We have 3x. We have 3x plus 1 greater than or equal to 0. So our inequality is x minus 1 into 3x plus 1 greater than or equal to 1 equals 0. Okay. Now this is the inequality to solve. Our critical points remains these values that we have here. So we'll make our analysis on the number line. This is negative 1/3 and this is 1. So we have this zone to test. Take a value in this zone. For example, negative 1. A value in this zone could be negative 1 and we'll put there. Negative 1 minus 1 is negative. Remember, we're doing multiplication. Put negative 1 here. 3 multiplied to negative 1 is negative 3 plus 1 is negative 2. So negative multiplied to negative is positive. We take a value in this zone. In this zone, a good example could be 0. If we take 0 and put for x, 0 minus 1 is negative. Multiply to 0 plus 1 is positive. Negative multiplied to positive, negative. Take a value in this zone. Example could be 2. Put 2 there. 2 minus 1, positive. 2 here. 3 multiplied to 2 is 6 plus 1, 7, positive. Positive multiplied to positive, positive. So from this analysis, this is what we get. So what is our solution set? Our solution set will be all real values such that since we have greater than or equal to 0, remember it means positive values. So our solution exists here and here. So we're going to have all real values such that x is either less than or equal to negative 1/3 or x is greater than or equal to 1. That gives us our solution set for which the gradient is increasing. So those set of values of x for which this function is increasing will be all values to the left of negative 1/3 and all those values to the right, including 1 of 1. All right. Our B says, this one is A. Our B says, let us find also the set of values of x for which that function is strictly decreasing. All right. A new qualifier has been put here, strictly. Strictly decreasing. What do we mean by strictly decreasing? Let's write this again. So we have minus x minus 5 plus 5. For strictly decreasing, For strictly decreasing function, the gradient function will be strictly less than 0. So this is a new inequality that we have to solve. The gradient function will be strictly less than 0. Our gradient function, again, what we had earlier on was, our gradient function was 3x squared minus 2x minus 1. This time around, we put strictly less than 0. Factorizing this, we remember we have the same factors. X minus 1, 3x plus 1, strictly less than 0. Okay, so we'll carry out our analysis again on a number line. The same analysis. This is negative 1/3 and this is positive 1. 3 zones again to examine. You take a value here. We already did the analysis. It was positive. We take a value here. We already did the analysis. It was negative. The value here, we already did the analysis. It was positive. So the same number line will be used. But this time around, look at it. We have less than 0. Less than 0 means negative. So our solution set exists only here in this zone. All right. Strictly less than 0 simply means that these endpoints will not be part of our solutions. Our solution will exist here, but the endpoint negative 1/3 and positive 1 will not be part of the solution. So we'll just get our solution set will be all real values of x such that x lies between negative 1/3 and positive 1, with negative 1/3 out and positive 1 out. So how do we write that? We have negative 1/3 less than x less than 1. Okay, so that is our solution set for when the function has a decreasing nature.